Hello. This is part two of our series about the Sharp Pocket Computer PC-G850VS. I bought mine a few weeks ago from Japan. So now, before I dive into the C assembler and basic programming, I wanted to find a way to send the program listings to the PC or download it from the PC so that I can grab maybe some stuff from the web or also edit it in a bit more comfortable editor and then load it down to the Sharp. So the Sharp has an 11-pin port. Let me show you, which is pretty flexible. You can not only use it as a serial port, but it also connects to Sharp printers. That's almost a full duplex port where you have two lines for output, including clock, and two lines for input, including clock. So this doesn't have a fixed bit rate like serial communication. Then there's a parallel input-output mode where you can set each bit or each line status from the programming languages in software. And last but not least, it has a PIC programming mode. So you need a special programming board for a PIC microcontroller. And it has the necessary compiler or assembler already built in ROM. So I think that's probably not of much interest nowadays with Arduinos and the Raspberry Pi Pico kind of being around, but was pretty cool in the days, I would say. Too bad that this really awesome pocket computer was only sold in Japan and never made it here to Europe. I think it was primarily sold to schools and colleges in Japan. So basically, we want to use the receive and transmit line. It can transmit up to 9,600 baud. We want to avoid using the signal lines. It also is capable of software flow control, but actually what we want to connect between the two computers, the Sharp and the PC, is just receive, transmit, and ground. Now, how do we do this? Well, the Sharp unfortunately insists on handshake, even though in the configuration it appears you can disable it and go without flow control completely, but you at the minimum then need to shorten RTS and CTS on the Sharp side. And there's also something else kind of somewhat peculiar, which I show you here in this diagram here. So the Sharp has logic level, TTL level serial communication, but it uses RC232 semantics. Now, what does it mean? So RC232 is a serial communication protocol that uses voltage up to minus 15 and plus 15 volt to indicate a bit, 1 bit or 0 bit. It uses positive voltage for the 0 bit and negative voltage for the 1 bit. So low is equivalent to a 1 and high is equivalent to a 0. Now, in regular TTL logic, so this is what, for example, an Arduino understands, and any USB to serial converter that speaks TTL is a 3.3 or 5 volt logic understands, has 0 volt for low and is a plus 3.3 or 5 volt for high. And that then stands for a 1 or the 0 volt stands for 0. And as you can see here, the Sharp has it exactly the other way around. So a low is 0 volt, but that stands for 1, and the high, that's 5 volt, stands for 0. So what you need is effectively a converter that not only converts the level from 5 volt TTL to, in our case, USB, but you also need an inverter that essentially flips the bits around. Otherwise, obviously, if you send 8 bits consisting of zeros and ones, it get all kind of mixed up and inverted. And so if you send, let's say, the character A in SQL, that's SQL code 65, or 41 in hex, then that gets inverted and it arrives at a different character. Now there are these FTDI 232 mini adapter boards out there, quite commonly used to program Arduinos. They can adjust to a 5 volt or 3.3 volt logic level. And there is a software available from ftdichip.com, ftprog, that allows you to essentially change the way these bits are being interpreted, both the signal and the data lines, and you can essentially invert it here. Now, unfortunately, the chip that I have looks exactly like this one here. Where do I have it? Here, I do have it. Also says FTDI on the back, but it's not being recognized by the software. So I cannot use this chip, unfortunately. Now, what I'm using instead is an Arduino Nano. It has 5 volt logic, and it is capable of also running a software called Software Serial, which is great because it turns any digital pin of the Arduino into a serial input or output line. But it's also capable of doing the inversion for us. So it turns a 1 that's being received into a 0, and a 0 into a 1, and vice versa, both into the input and the output direction. What I've here now is the 11 pin port kind of just be moved here to the breadboard, so I have a bit of an easier time making the connections here. The TX is connected to the RX of the Nano and vice versa, and then the Nano essentially translates this and sends everything it receives through these software serial ports down to the regular serial port, which is then via USB connected to the PC. So let's try that out. I wrote a little basic program, and that essentially sends some character, in this case character A, down to the serial COM port. It opens the COM port and then prints out that character. It tells us that it has sent this character, and then runs a loop. So it does this over and over again. Now we run this in run mode, and what you can see, it flips to busy. Now busy is an indication that the Pocket Computer is waiting for something. It is effectively waiting for a signal from the receiving end that the data is being ready. Well, that the other device is ready to receive the data. And obviously we don't run these lines here. And actually Software Serial and the Nano doesn't even have these lines. So we disable that in code, or effectively it's not even programmed in code, so it's never been implemented in the first place. But we also need to shorten then RTS and CTS on the G850V side Okay, so we do this now. So this is pin number 9 and pin number 4. So the yellow and the white. And you can see it's still busy. So, but just in case it needs that to be in place right from the start. So we run again, but same problem. So it's still, even though we've created a connection between RTS and CTS, which usually then sort of makes the Sharp signal itself that, oh, yeah, the other side is ready. So it's, of course, fake, but it doesn't work in this case. So I discovered that if I add a 10K resistor between these two signals and plus 5 volt, then it actually works. So let's stop again. You have a 10K resistor. So we connect here pin number 2. That's plus 5 volt, the red wire, and one of the white connectors like this. Okay. And now we try it again. And now you can see it's no longer busy. It jumps to send, which means it tells us it has sent the character. And we now switch over to the PC and we run a little piece of software terminal program, which we can connect to, in our case, the Arduino says hello on COM8 with 9600 baud. And we'll see if we receive something. And there it is. You can also switch to hex view. It's a bit easier to see. You see lots of characters, but not just, let me just stop, disconnect. Not just the A, which is hex code 41, as you can see here, but also a cartridge return and line feed. So what we now try is we're switching to C, and we see how that works. And I created a little program here, which essentially opens the stream in C. I know it looks a bit strange with the line numbers here. So it opens STD aux in A+, which means read and write. It then tells us that it successfully opened the stream, and it then prints a few A's. Then it closes the stream, and it tells us that it just has sent the sequence. So let's try that. So we switch to C. We compile the code. Okay. Now I switch so you can see what I do, and I clear the terminal here and connect so that we receive sequence. And if I now hit G on the Pocket PC, it runs software, and oh, sorry, that was covered by the window. It has sent the sequence. As you can see, it has only sent the A's. Okay, I can do that again. You can see it the moment I pressed go, it sent another set of A's, and then it stopped. So in C, it does not add additional characters, no line feed, cartridge return, and we now try to send the program over. And for that, I clear the data here, and I send the connection in this terminal program here to capture whatever it receives. And we call this demo.c. And now I switch to the text editor, and under S for SIO, serial input output, I now press S again for save. It quickly blinked sending, and what you can see here is the text that we've received. We now stop capturing, and I can show you the file. And you can see it. So looks a bit strange again, kind of with the line numbers. And you can see the Sharp puts a special character at the end of the file, and this is when it receives the file back, how it can tell that, oh, okay, I reached the end of the file, and I can stop now. So that's important to make sure it knows when the complete file has been received. So we now try to receive a file. So for that to work, we'll clear the text editor. So I press del. Okay, to delete. Yes. Okay, we're now going to edit mode, so I can show you there's nothing in there anymore, completely empty. And we now go into receive mode, L for load. And now we send the very same file over via connection, send file, demo C, open. We've sent it. The Sharp has received it. We now go into the editor to see if we successfully received it. And here you can see it's back again. So we can send and receive files via the Arduino Nano and the PC. So we can now explore a bit more the programming languages and what we can do there. And also planning to use, instead of the Nano long-term, an ESP32. There's one of these here. Actually, it's just a carrier board with some additional electronic, like a USB interface and so forth, voltage regulators, and then it makes the I/O pins a bit more accessible, just like an Arduino Uno. But the extra chip that I'm going to use is just this ESP board here. So it would be quite small, if you can imagine. Kind of it doesn't take much space out there, so you can plug it in. Fortunately, the 11-pin port also provides 5-volt power. So I just need to work out how much power it will consume. As you can see from all the testing here over the last few days, the battery sign is already on, so I assume that I have to recharge the batteries. So so that's the first few steps into exploring the Sharp Pocket Computer PC-G850VS. Hope you liked it, and you join me next time when I explore a bit more the programming languages of the Sharp. Take care. Bye-bye.